Carsey here. In this question we have to find an expression for the gradient of the line joining these 2 points and to simplify our answer. Now let's remind ourselves of what we mean by gradient of 2 points. Suppose we have point A, x1, y1, point B, x2, y2. Line joining these 2 points. Gradient formula tells us y difference, y2 minus y1, divided by the x difference, x2 minus x1. Be careful that the point you start with in these subtractions, this is point B, y2, must be the same top and bottom. We could swap them round, it's the same as y1 minus y2 over x1 minus x2, but certainly whatever point we start with, we must do the same, start with the same point top and bottom of this fraction. Anyway, there we go. So here we go. Gradient of the point joining, of the line joining A to B, with the y difference, that's 4p squared minus 9 over the x difference, 4p minus 6. So that's the first stage. Now we have to simplify this. So there are two things going on. In the top expression here, we've got two square terms. 2p times 2p, that's 4p squared. That's a squared term. This is a squared term. And difference of two squares can be factored. A minus b times a plus b. That's the pattern. So in the case of 4p squared, we've squared 2p. In the case of 9, we've squared 3. So we would get 2p minus 3, 2p plus 3. You can always check these by doing firsts, outsides, insides, last to check that when you multiply them out, you do get back to what you started with. So 2p minus 3 times 2p plus 3. Let's look at the denominator, bottom of the fraction. There is a common factor of 2 in each of these terms, which we can take outside the brackets, be left with 2p minus 3. Again, check it out, multiply out the brackets. 2 lots of 2p is 4p, 2 lots of negative 3 is negative 6. So we're okay there. And we'll notice that this fraction has 2p minus 3 as a factor top and bottom. We can actually divide top and bottom by that factor, 2p minus 3. We can cancel that factor out. And we're left with 2p plus 3 on the top, 2 on the bottom. And that's the simplest form of that gradient. If we go back to this stage just by way of explanation, why don't we consider 2p plus 3 over 2 times 2p minus 3 over 2p minus 3. And you'll see what's happened here. On the top of this we have 2p plus 3 times 2p minus 3. In the bottom we've got 2 lots of 2p minus 3. 2p minus 3 over 2p minus 3 is just another way of writing 1. We've basically got 2p plus 3 over 2 times 1, which is just 2p plus 3 over 2. That's why you can cancel out if there's a factor that's the same top and bottom. So, that's Mr. Carsey signing out. Hope you enjoyed the video.